Hello again, everybody, and welcome to the second video in our right triangle trigonometry series. We're going to look at the tangent ratio again, but now we're going to focus on finding lengths using it. Before we get into the examples, let's quickly review the tangent ratio again. The tangent ratio is simply a comparison of the length of the leg opposite the angle you're dealing with compared to the length of the leg adjacent that. Okay? So again, what you remember me writing in that previous video was tan theta equals opposite over adjacent a lot. Okay, so again, whenever you compare those two sides in this order, we call that the tangent ratio. We're going to look at two others in this unit, one called sine, the other one called cosine. But today, we're going to continue with tangent ratio. So let's get right into it. Determine the value of the missing lengths. Okay, so the missing length, we're looking at this AB, okay, side AB. So what side is that? Well, it'd be the side between the letters A and B, so that's going to be right here. I'll put a question mark there. Now, one thing about triangles is that we always use capital letters to represent the corners, the vertices, or the angles, okay? So A, B, C, you can see are capital letters. Now, the sides, though, we always use the smaller case version of whatever the angle is. So you can see here the hypotenuse I'd write as little b. This is big C. So I'd write this one actually as little c. And then this one over here, this side would be little a. So you can use the AB like I've used at the beginning of the question, or you could use these smaller case letters. Whatever you want to do. People use both, so they're both correct. Depending on the textbook and the authors, whoever wrote the textbook, they'll have their own kind of favorite way of writing things. Anyway, let's begin. So I use the exact same ratio. Tan theta is equal to the opposite leg over the adjacent leg. Now, we are dealing with AB. I got lost there for a second. We're dealing with this AB. The other thing we have to deal with is we have to, I guess, figure out first. Again, this is the second day in a row I'm having trouble speaking. The very first thing we really should do is figure out what the angle that's been given in this question. You can see here it is this 30 degrees. Now, if they ever give you more than one angle, then you'd simply choose whichever angle you want to work from. But in this question, they only give us one non-right angle. And remember, this theta is always going to be a non-right angle. Okay, everybody? So even though I have a right angle, I'm never going to use it. So I'm going to write this now as tan 30. So that's a difference. In the previous video, that was always left as a letter, and we'd find out what the angle size was. Today, we're going to have the angle sizes, and we're going to be looking for one of the missing legs, okay? Either the top number or the bottom number, the opposite or the adjacent. Now, again, from the other day, we know that according to the angle, we name everything. So I'm going to use a different color because it's starting to get pretty cluttered in here. So across from 30 would be my opposite. And now adjacent. Now, again, there's two adjacents, right? Like I can go here or I can go here. Like which one's adjacent? Well, it can't be this one because that is your hypotenuse. It's not my adjacent leg. So this would be my adjacent leg up here. So remember, we're never going to choose a hypotenuse when we're looking for a leg. Okay, so based on that, I don't know the size of my opposite, so I'll leave that as C. Okay, I could also have written that as AB, whatever I want to do. But the adjacent I do know is 10. Okay, so I use the tan ratio, and I use this general form as a structure to help me fill some things out. And now what I'm going to be able to do is use a proportion. Now remember, a proportion is when you have two fractions set equal to each other. So if I write tan 30 over 1, there's my first fraction, and then C over 10 is my second fraction. Now, you might be wondering, tan 30, like how is that a number? Well, it is a number. If you type tan 30 into your calculator, the calculator will spit out a decimal number. So I'm going to leave it as tan 30. I'm not going to write it in its decimal form. And just like in the previous video, the reason I do that is I think it's really kind of a waste of a step. When I go to calculate my C and I type in my tan 30, my calculator will change it to a decimal at that point. So there's no need for me to change it and then have to pay attention to all these decimals. I'll just leave it as this neat and tidy tan 30. Okay, now back to actually solving. So once I plug everything in, I'm going to treat it as a proportion, and I think you've likely done proportions before. All we do is we just cross multiply. And actually, I'm going to draw it the other way. I always bring my variable to the left side, so I'm going to have 1 times C equals, and now I'm going to go the other way. This is going to be now 10 times tan 30. Now, if you wrote tan 30 times 10, that is fine, everyone. Okay? 1 times c is c, and then now the length of c will be equal to 10 multiplied by tan 30. Make sure your calculator is in degrees before you continue. 5.77 is my answer, and then I should have units there, and I do, so that is centimeters. Now, again, your calculator, it's really important that you understand the logic. So from the calculator that I was using today, I'm not using my phone calculator, which is good. I have a different calculator. But again, this one I'm having to actually type in my values first. So I typed in 30, then tan, and then I hit equals, and I got a big decimal. Then I multiplied that by 10. The calculator that I left at school today, the one that I like to use, I actually, when I hit tan, I'll see the word tan come up, and I'll hit tan, I'll see the word tan come up, I'll just type in 30, I'll put a bracket, I'll close the bracket around 30 so it doesn't think that I'm doing more to it, and then I times it by 10. However you want to do that, or however your calculator works is great. Just make sure you know the logic of it. And if you're making mistakes, like it feels like you're doing it right, but you can never get the right answer, come talk to me or whoever's teaching you, and we will figure that calculator out, because that's always annoying when that happens. Anyway, I am done now, this A. That is all I have to do, and that's all I have to do for all these questions. B, we'll set it up again. Again, I'm always going to be using a proportion, so I might be solving my letter or my variable, the missing side, might be in the numerator or denominator position in this question, but I'm always just going to cross multiply and solve. So hopefully this won't be too tough for you guys. Okay, so tan theta equals opposite over adjacent. Again, I got to start with an angle. I can see they gave me a tan 70. Once again, if they gave me more than one, okay, like we know that this has to be 20, okay? If they would have given me both of those, I could work from either one. It's just I might not be able to use the tangent ratio in it, okay? So I'm looking for xy, by the way. The xy is right here. So based on 70, the opposite is once again my xy. So you can use it you can write it as xy or little z, whatever you want to do. How about I write it as xy this time, because I did not do that the other time. And then now my adjacent has to be the 5. Okay, and then now I have everything set up using that tangent ratio. Now this is where I turn it into a proportion, and then I'm going to cross multiply and solve. So 1 times xy is going to be equal to 5 times tan 70. 1 times xy would just be xy, and then 5 times tan 70 equals 13.74, and then what's my unit? It is centimeters again. So pretty quick. If you understand how to plug everything into the proper spots in your tan ratio, you should find this pretty easy. Example 2. Similar type of thing. Determine the value of the missing side lengths. Okay, EF. EF is right here, everybody. I can call that D. Typically, I use the smaller case letter. I won't use EF in my solving, but again, like I just did in the previous question, you definitely can. So tan theta equals opposite over adjacent. You don't have to write that out each time. I do that just for you guys so you can see what we're doing. You always start with your angle. So okay, this is now going to be tan 20. I'll name everything according to my angle. So that means 3.5 is the opposite. And then the thing I'm looking for, this D, is going to be the adjacent. So now you can see the variables in the bottom. How will that change things? Well, it does change things a little bit. There's one extra step, but I don't think you're going to find it hard. Okay, so I always bring my variable to the left side, so you can see I'm doing that. So that's going to be now D times tan 20 equals 1 times 3.5. And I want D to be by itself, right? I want D equals in the end. So the way I do that is I just divide by tan 20. Why am I dividing? Because right now it's D times tan 20. To move something to the opposite side, I must perform the opposite operation. So tan 20, tan 20, D equals 9.62. And that is centimeters again. So when your variable's on the bottom, you're going to have this extra division step, but it's division every time. So again, that's not too difficult. Let's look at another one here. Vx. So Vx ends up being right here, and it is opposite of this W, so I'll have my little W there. And again, we need to start with our angle, so I'll go right into it without writing that general form down. Tan 42 equals then 7.2 over W. And again, because that's opposite, and that'll be adjacent. Okay, make it into a proportion. Now I just cross multiply and solve. I want to bring that W to the left side. So W times tan 42 equals 1 times 7.2, which we already know is just going to be 7.2. Then I want W by itself, so I'm forced to divide both sides by tan 42. Now, again, tan 42 is actually a value, okay? I know it feels weird to have a word in there, but that's going to be a decimal. So I'm dividing that thing by itself, so that's why it equals 1, and I don't need to write down anymore, so that's W is going to be equal to, and with rounding, that will be 8.00, and then again, centimeters. Okay, so now the final example, just a situational problem. So why we have these is that what we're doing a lot of times just working on these triangles that don't really have any meaning. They just have these values in there. The reason we do that is to practice these skills. And then really what goes on is that we'll have situations in the real world that'll have triangles in them, and then we'll have those skills that we've learned on these kind of more made up triangles, and we can apply those skills. So here you can see at a horizontal distance of 200 meters from the base of an observation tower, the angle between the ground and the line of sight to the top of the tower is 8 degrees. Okay, so they're talking about right here. So the angle upwards there is 8 degrees. How high is the tower to the nearest meter? The diagram is not drawn to scale. Okay, so some things we need to add in here. It says a horizontal distance of 200 meters from the base of an observation tower. Okay, so that means this here is 200 meters. Here to here. And actually, I guess if I drew it down like that, I guess it'd be like that. So let me just get rid of this here real quick. Yeah, and then I'm looking for this height, so I can just put an H for height. So starting with my angle, make that the 8. Tan of 8 degrees equals, what's the opposite? The opposite happens to be the height in this case. And then the adjacent is 200. So I don't worry about if my variable's on top and bottom. I just solve it. When the variable is on top, it is that shorter version. I'm always going to bring that variable to the left side. So 1 times h. Then on the other side, 200 times tan of 8 degrees. Now, if you're wondering, it doesn't matter again if I go h times 1 or 1 times h. And then on the right side, 200 times tan 8 or tan 8 times 200, you guys. In multiplication, the order doesn't matter there. Just multiply them together. Like 3 times 2 equals 6 and 2 times 3 equals 6. So we'll get the same answer. Anyway, h equals 28.11 meters. And it says over here the nearest meter. So that would be about 28 meters. Okay, everybody. So that's the tangent ratio when we're finding lengths. So when we're finding lengths, we just use a proportion. When we're finding angles, in that previous video you saw that, we just used that inverse idea where we just told the calculator to really work backwards from what you've been programmed. Okay, so I hope all this made sense. If it didn't, make sure you talk to your teacher or come find me and I'll talk with you. Have a great night, everybody.